say? You've got to share your screen. Guys, we have like too much pizza.
Already like 20 pieces.
Dude, I can't right now.
Stress. You're cooking right now.
Oh yeah. I just speed ran some primos and shit. So do slideshow? Okay. Hold on.
I haven't met you today.
Is that true? Probably.
So, that's not like a shut
Can you tap that?
No, it's working.
No, I need to. Okay.
I'm gonna just keep it on.
You still touch it.
After we get rolling, could you set up Michael?
There's nothing we can do about that. It's one or the other. If both are on, only one works.
So, does David know that?
David? He's just gonna have to hand off the microphone. So, can you get David and tell him?
David.
Can you press hide?
Did you skim QR? I say thing.
You brought your own pizza?
They gave it out.
To go.
Oh, for you to go?
Yeah.
Oh, I don't want anyone to know.
You know that you're a superstar? Yes.
What's that?
You know that you're a superstar for the other people? That's cool.
Avocado.
Can you join the thing and see if the sound is working?
From the iMessage you sent.
Yeah.
Yeah, let me do that for you.
Wait, not here.
It is popping out. Right here.
Okay. Can you see if you hear?
Hello? Wait, where's the mic input?
Well, no. It's just you hear stuff. Yeah.
Yeah, it's working.
Okay.
Working directly, like.
Yeah. No, don't.
Yeah. I gotta control myself.
Yes.
Wait, really?
They just sent it to me. We should sit down and it's extensive and we're going to take a really narrow approach. Log in, forget password, that's it. No, doing this UConn, you kind of think you're trying to do something weird. Personal email. It's all good.
Anyone broken about it?
Is there anyone online?
One person.
Oh, that's me.
No.
Oh.
In addition to you and me on there. One. I don't know.
So we might have
Just three.
the man.
What'd you say? Yeah, I saw. Yeah, I'm excited. So we're gonna work on getting A2 tomorrow because she's not in the office right now. So
Work on getting that.
yeah, A1 is unavailable.
Yeah, it's unfortunate.
Yeah.
We'll do what we can do. That we'll pack that one.
Yeah.
Yeah, that's what they say. So I gave before she told me, they sent an email. Like, what do you want him to do? And this and that.
Yeah.
So I don't care what he does.
Yeah, just as long as he.
I don't care if he comes and blesses us for 5 minutes. I don't care if he
Yeah.
comes and tells us what we should be doing for an hour.
Yes.
Or anything in between. The easy part is a discussion or fireside chat. Because we put somebody else up there, like you or somebody
Yeah, it's
who has some good questions. And,
yeah.
But what we do then is we prepare the questions in advance, make sure he has them.
Yes.
You know what I mean?
Yeah, definitely. He probably needs all the questions in
Yeah,
advance.
we do that. It's like now.
Yeah.
Like yesterday.
It's like 2 weeks, like from yesterday. 3 weeks from yesterday.
Yeah, so we'll see. Get the room no matter what.
Yes.
Just assume it's going to happen.
Yeah,
And
definitely.
also ask if that Schreiber reading room evidence.
I haven't checked that one, so I can look at that one tonight.
That's the one that's above you. Walk into
Yeah.
the building on the other side by
Yeah, it's next to the library. Yeah.
So I would love
it's above.
Yeah.
fully explain complex. I think that's going to be a winner. You liked it? I told you that.
Would you- 21st.
They can see the gesture. And you could go back on that. We could have used that.
Yeah, but got you.
You guys ready?
Yeah.
Feels like we are.
How's my Linux machine coming?
I've not worked on it.
So I've been actually not working on it, but been learning more about Linux.
Okay. Just want to know how to run Python. Cloud Python.
Cloud Python.
I'm going to do some work this weekend.
Okay.
I keep forgetting how probably homework, exam next week.
I'm not thinking anything about school right now.
Thursdays I'm packed. But I do have office hours.
I'll tell you what's happened in the past hour after.
I would assume
The
chaos.
WebEx. So that one's good right now. It's yeah. Forget it.
Wait, what happened to order 20 pizzas, boxes of pizza?
Oh shit! I didn't see it.
I assume it's going to be his phone and his movements. Doesn't have that.
It does. We have a guy. Amazing guy.
1 second. It's a pizza. Right?
Yeah, it's a pizza.
Good afternoon.
Good afternoon.
You're gonna be like seeing me like fidgeting.
Who? Fidgeting.
Fidgeting, yeah.
What, me?
No, me.
Oh.
So basically, I've been doing this the whole day.
Oh.
Let me show you.
I should probably get something to eat at some point.
A nice little stress ball would be nice.
Yeah, it's definitely.
You know what would be good for you right now? Mango tea.
You know, I've never had tea before, so
Really?
yeah.
You should try it. What?
Bro, there's like no percent sign.
Yeah, you can. Yeah, you can. No, use the mic. No. Use the mic. Yeah, but it mic straight. Yeah.
No. I mean, just keep doing your thing. I mean, if you want, I can get you smiling, or I can get you laughing, or I can get you like talking, whatever you want.
Any and all will be fine. Because I think I look good.
You look good right now. Just keep laughing at me.
I could definitely pretend. If someone could
Remember when Tendai, the first joke? What was that about?
Oh yeah, I have killed him before and I have never killed him again. That was not good. Alright.
I gotta go out.
No, maybe I won't.
Yeah, get the mic. Not yet.
You want LinkedIn? Yeah, I got you.
No, we're not gonna start yet. Just
Not yet.
make sure everyone's enjoying themselves. Everyone grab like the last minute so we now and get started. If you guys can all check in, this is how we get funding, so we would appreciate it.
Yay!
Hold on, 1 second. Hold up.
I don't know how to. I don't work these really.
Yeah, try it again.
Sorry, I'm only computer science. I think it works now.
Yeah, it's fine.
I think I'm loud enough that I don't need it, right?
It's good now.
Point it right here, like this, like down, like that, like your hand. No, I said
You said point it down.
like down here, like down here, and then it should like whenever you find that.
It's
sweet
fine
spot.
now. Yeah, we're good now.
I really don't want to use this mic. All right. Well, thank you, everyone. This looks like a pretty good turnout for our first event of 2024. So thank you so much for coming. Today's event is focused on data analytics, machine learning, and how new age technology and finance can work together in the future. With UConn being a bit of a hub in financial technology, many of us have had the opportunity to implement machine learning and explore these possibilities when working with it and data. And to speak more about this, we have two members of our sentiment analysis team here to speak on it. So if we could welcome Dedeep and Harris to the stage.
Hi guys, looking around the room, I know a lot of you, there are a lot of familiar faces out in the crowd. My name is Dedeep and this
I'm Harris.
So we are both a part of the sentiment analysis project and we have been leading it since a lot of semesters. And we've come a really far along, we've made a lot of progress since the beginning. And we're going to explore what we might present in the future in this meeting as well. So without further ado, let's get started. So, regarding the sentiment analysis project, there are three main divisions, which a lot of people that I see right now have attended a previous event, which we talked about this, but just like for the new faces in the room. A generalization for the project, we can break it down into three different steps. The first phase, we're going to talk about the research and analysis phase, which is where we understand how the model is performing, what the model is actually scoring, and how it is scoring. We also learn about how we actually perform the sentiment analysis. We also then go into like further about how we store the data, how we actually run the sentiment model. Then comes the data and organization stage, where we utilize Google Cloud Platform, where we store the data, which are like earnings calls and the scored sentiment scores, the weighted sentiment scores, the ratios for the ratios for the keywords for the sentiment scores in the Google Cloud data store and the bucket. And we analyze that for first, because data organization for any sentiment analysis project or any like data science related project is really important. And then we actually run the sentiment and make sure everything goes smoothly and that it's again stored in the Google Cloud Platform. And Harris could elaborate on the aspect of the project itself.
So the team just did a very good job just explaining the nitty gritties of the project. So I'm just going to start off by talking about the research and the analysis aspect. So all the work we do every week on Fridays, we meet with analysts at State Street and we show them the work we have done, and that includes like actual data that we generate using our sentiment analysis models through conference calls, the graphs that we generate, and we use those information to find any correlation to check if our models are right and are wrong. So all of our work is kind of based on the feedback that we get from them. And other than that, the data organization aspect is really, really important to us this year in GDSC, because it's really important that we collect and store all of the work and data that we collect, because we want this to be an ongoing thing. So students that graduate this semester don't just leave with their work and forget about it. The work continues to develop, and we just continue to develop what we're working on.
Regarding that a little bit, we at the moment are still a small scale project, but as Harris was mentioning, the data collection part is a really important step because we're trying to scale it to 3,000 and 6,000 companies. So when an analyst that wants the data, they go on the platform to get any sort of information. It's accurate, fast, and it's ease of access for every analyst that they want to use. Another thing as well that Harris mentioned, this project itself is going to create a template-based learning for future students after us, and you guys could sign up. Maybe eventually it might be a course as well that's offered at UConn by Professor Ikuhachi. That'd be really cool to see. Um, yeah, yeah, yeah. So yeah, just keep an eye out for upcoming events and anything related to that for the UConn campus itself. Next, we're going to talk about the project highlights. We have struggled a lot, and we've come a really far distance since our last event. In the last event, we were still in the beginning phase where we were talking about how we were going to select the model and the basis of how sentiment analysis works. We gave you guys definitions on what sentiment analysis is. And from there, we have come as far as to say we have chosen the right model. We have been running the data constantly, as Harris was mentioned a little bit before. We have been in constant communication with State Street, which is right down the street. And we've been talking with their analysts about how accurate our sentiment model is, if it's like going in a direction which is going to help build the template more, allowing to further, you could say, elaborate in a way where it's more generalized for not only earnings calls, which we were doing currently, but for other conference calls and stuff like that. And regarding our future goals,
so just referencing our future goals, we have spoken in depth about these at our previous events as well. So one of the things that is really important to me as the president of GDSC and a lot of the people involved is to create a foundation ecosystem for students at UConn. And what that means is that students are able to come and learn even if they don't have much experience, and specifically promoting machine learning and AI education, especially for students that don't have much experience beforehand. And that can be done through projects, through workshops. We have projects in machine learning, which is the sentiment, AI, cybersecurity, and we hold a lot of workshops throughout the semesters where students can come in, learn, engage, and just kind of start their careers early on.
If you guys are further interested on how we actually run the sentiment analysis model and any sort of documentation, make sure you scan the project link with your cameras, and it's just going to take you to a GitHub, which has a bunch of documentation and our actual code that we're using at the moment. So if you're interested, just take a picture. I'm going to pause for a little bit. Yeah. Okay, cool.
And finally, for our main event speaker of the first that. And finally, for our main event speaker of the night, I apologize, guys. We have a veteran of the industry here to speak with us. He's the current head of data science at Bloomberg America, and has definitely forgotten more about data analytics than I have learned so far. So I'm very excited to hear what he has to say to us, and I hope you guys all are as well. So if we can get a round of applause.
Thank you very much. It's I just undo this. Yeah. Got a couple of things here. Everybody, it's a pleasure to meet you. Quick question: how long do we have? As long as we want, an hour. All right, good. You guys have nothing to do. Oh, well, I won't take up all that time. All right, good. So before I get started, and I'll give kind of an introduction, but I think the most important thing, like I went through your GitHubs, kind of taking a look on the public atmosphere around what's available, and it seems like you're doing really interesting things. I just say, like, I think that it's very fortunate to be able to have this relationship that you have with State Street. Like, they have tremendous amounts of data, and the best way to learn is just by doing things. Whether it kind of what you were talking about, of interning for the university and thinking about how do you bring files together, or being able to work on prototypes with different companies. The real thing is just like start to get access to data, start to try to solve problems, and then you'll figure out where you actually want to go with your lives from there. But so as we start off, I just kind of was hoping to take some thoughts, get to know each one of you to the extent that we can, and have a little bit more of a communicative conversation throughout here. And so maybe like just, you have an orange sweatshirt, so I know that you decided you can handle this. Can you tell me a little bit about yourself, kind of what brought you out here today? What are some of the things that you're focusing in on? And just know that others will probably be called with similar questions.
My name is Sergio Monzafar. I'm a sophomore at UConn Stanford. I'm a computer science major, and I'm thinking of either doing software development, cybersecurity, or a combination of the both up in the store campus.
That's great. How many other people are thinking about software development or cybersecurity and trying to think through like where do they want to apply their times, just by show of hands? All right. Now, if I broke that down to cybersecurity, keep your hands up. All right. And software development. Okay. So that's that side of the room. What about this side? What are you, sir? Tell me a little bit about yourself and what keeps you interested.
Yeah, hi. I'm Pawan. I'm from business analytics and project management graduate. I'm looking more towards business analysis and maybe working with the data, using some BI tools or more bringing out some insights from the data.
And what have you done so far in line with that type of interest?
So, like, I do have work experience earlier working for Deloitte in terms of business analysis, forecasting the future based on the past data, using some applications. And I'm just a freshman here at UConn. I started this spring.
Great. Yeah, that's great. Thank you very much. And in the back with the computer, can you introduce yourself and tell us a little bit about what keeps you interested?
Well, my name is Valerie Wimpy, also a very good friend, and I am a digital media motion design major. And I guess like I'm just interested in learning more things. I don't know anything about this. I like heard it from a friend, so I was like, why not come here and learn a bit? Extend my reach.
Cool. Well, that's amazing. So what I hope to be able to do today is to try to balance around the topics that will be of interest to everybody. We'll get a little bit technical, just to like add some grounding, but then hope that we can also provide the application, the problem to be solved, some interaction models, and certainly like let's keep this communicative throughout the entirety of the conversation. So one of the things that they asked me to do was not just talk about like the data science and the technology, but to give you a little bit of context as to how I ended up here. So I grew up in Brooklyn, New York, and as a child, and I'm actually impressed by each one of you that I've heard from and that I've had conversations with as to kind of the focus that you have, the things that you're interested in, and the things that you've been trying to do to be able to better understand that, increase your skills, and be able to apply that in the future. I grew up not really knowing what I wanted to do, right? I started coding when I was in high school because I wanted to create a website, and it was hard back then, and I just found it to be interesting. I had this idea growing up in Brooklyn and going to a pretty prestigious school in Manhattan of this feeling like I was always in a different world, right? And in my environment in Brooklyn was very different from my environment at my high school. And it took me a while to kind of accept that I was an all-American basketball player, but I was really smart, right? And I liked math. And so that's really shaped me. And like one of the ideas that my mother gave me was this idea of I don't have to be one thing, right? Like she gave me the idea of Lorenzo de Medici and Michelangelo and the Renaissance man, and just like be the best at every little thing, and that's kind of who you are. You don't have to be a square peg in a round hole or whatever the concept is. And I think that those types of people tend to do very well at finding where the world's going, or at least I believe that for myself, right? Because you're a experiencer, or I was an experiencer of lots of different things that were coming in. I was always used to how do I quickly learn enough to decide whether I really want to spend my time in this area. And by being a generalist, it forces you to think, or I'm going to speak in the I. It forced me to think about not just the silos of the place in the world I was in, but also the interconnections that took me from one place to the next, and what I needed to keep about myself in one place and transfer into the new one, and what I needed to let go. I bring that up because that's the world we live in today, right? There was a world where technologists were kind of just in the back, and they were just doing technology things, some core infrastructure project, and totally disjointed from whatever was happening upstream. But in order to today, whether it's doing forecasting analytics or thinking about media optimization or cybersecurity, you can no longer stay at that bottom layer, right? You have to be able to understand the entire workflow across the layers. And so the people who are going to be successful in this new world, where now technologists aren't just speaking to technologists, but you have to speak to salespeople to understand the client's problem. You have to speak to business owners to be able to understand how you go about solving that problem. You have to be a Lorenzo de Medici and understand lots of different pieces, albeit you have to be specialized at something, right? Jack of all trades. If you're good at everything, you're okay at everything, you're good at nothing, whatever the saying is, right? So you really have to kind of figure that out. Now, going to like the name of this club, the Google, which I think can be just generally spread out to be a cloud side. It's this cloud adoption in this world that you all take for granted that others in this room don't, right? That's not only enabling this cross-functionality, but requiring it in this move forward, right? So in a world where you were in as we were talking about earlier, physical infrastructures that are like down in New York 1 or some data center out in Canada, there was only one way to access it. So you didn't really care everything that's happening before. But with the cloud, that's brought the processes to a place where they're integrated into everything that you're doing. So cybersecurity is going to be as important to the success of a campaign as the data that's flowing through it. And the data that's flowing through is going to be as important as the processing power, and whether you have CPUs or GPUs when it comes to the forecasting. So I just wanted to start off with that portion as to like, as you think about where things are heading, and for me, as I was sitting in your shoes where I knew that I like to do lots of different things, it's not always necessarily about what do you really care about, right? I like that you said multiple things in cybersecurity, but perhaps start thinking about what is it that you're passionate about? What do you enjoy? How do you like interacting with people? And then that will push some things askew that aren't interesting. And then other things you'll continue to get better at as you move forward. So with that in mind, just keep that context of it's okay to be good at lots of different things. Find what are the things you find interesting, whether it's sentiment analysis or cybersecurity. And perhaps through this conversation that we have, there will be certain things that you gravitate towards and you may want to dive deeper in, and we're happy to try to help facilitate that. And other things where you say, that's cool, but it's not interesting to me at all. And there are a million things you can learn. You don't have to feel like you can learn everything. All right, so hopefully that's helpful. In between that, just for background, like I went on to I started off as a discretionary investor, so I understood those workflows. I had an idea about how big data was going to change the investment world, and I took that idea. Actually, I'll go back to here, looking for funding for a startup idea. Ended up having conversations at JP Morgan when I was coming out of grad school, looking for funding, where they eventually said to me, "We're never going to invest in your business." So that was deflating. But then they said, but I heard Jamie Dimon talking about this idea of big data and how the firm needs to do it. You seem to know what you're talking about. You seem to feel like you might be able to survive in a room with him. And they put me in a room with him at 26, 7 years old. And that ended up being the spark for JP Morgan's Big Data and Machine Learning Group, which we then grew out called Intelligent Solutions. About 150 people by the time I left, and now JP Morgan is certainly leaps, years, decades ahead of their competitors as it applies to the application of AI. And a lot of that is because of the early work that we did cleaning up the data infrastructure, right? And I've heard a lot of these projects like ETLs are painful. You don't even fully understand it. Like with logical data models and the interconnectedness of reference data sets and having cross-asset data stores over here and others that only speak, one's in COBOL, one's in SQL, like those were very painful approaches. So he was thoughtful enough to say, let's just build this next generation on top of it. Think of it as an orchestration layer, centralize that, be seeding that, and then eventually dissolve it once we've achieved our goal and put it into the lines of businesses. But getting close to the decision makers, I think as you think about your next career or when you enter in, be in things that are aligned to like the decision makers in the organization. All these organizations are going through dramatic changes, and you want to be a part of doing the things that the CEOs are talking about, right? And bringing those things to life. And through that process, you'll learn where are we heading next, right? And all of this, as to how I got here, was a view that these conversations that were taking place would actually happen. And frankly, where we go next, you'll be the ones to determine around that. So I just wanted to touch upon a few of the things that, this doesn't really matter, a few of the things that are interesting to me that will helpfully tie into where the world's going and give you a couple of flavors around that. So let's assume for now, we'll take for granted the extraction process. Like Bloomberg as an organization, started off with a terminal and an idea that people would actually want access to the information and have that at their fingertips in real time. And Mike Bloomberg buying people coffee and running through Merrill Lynch to be able to get deals, right? And now it's grown into a huge organization that has basically any piece of data that you'd want access to, 116 different data products, probably 50,000 fields, and just a large mammoth beast that has the information that's required to drive this next level of ML and AI. But what are some of the things that we would actually think about doing it? So in investing, there's this idea of factor ranking. Who's ever heard of a factor, an investment factor? I don't want to take it for granted. Okay. So a factor is quite simply, let's see if I can give you an example of it. Anything can be a factor, right? All a factor is it's a piece of information that you know about a large universe, and your goal is to see if you can distinguish investment performance based upon the results of that factor. In this case, I heard that you guys did some analysis around sentiment and applying that over to ESG. So you can think of a factor as you have the S&P 500, you've now done your sentiment ranking off this, or sentiment scores, you turn that into a ranking. And some of the companies are going to have very negative sentiment. Some of them are going to have very positive sentiment. And your ask is, so what? Well, if that factor then turns into that companies with positive sentiment have better performance over the next 3 months than companies with negative sentiment, great. Your work was actually valuable, and maybe it can go into an investment research process. If not, then maybe you should continue to work on. So a factor is really just taking a universe, scoring the data that you have, and then leveraging that as a ranking for some sort of predictive signal when it comes to investing. So ESG, everybody here has heard of ESG. If not, I'll talk about that a little bit. That's this whole thread around like that your generation is really pushing of environmental awareness, right? So E represents the scores that people are giving you around your environmental friendliness. S is around your social awareness, and G is around your governance structure. So that's been pushed, and a lot of the question is, okay, well, does that actually lead to returns? And it's one thing for companies to say, we want to do this because we want to be good or nice or good citizens. But we know more investment dollars come if you can provide that with a actual return on capital. So here what we're doing is we're taking every piece of information that we have about companies related to ESG. We're linking that into our security master associated with companies. And then we're also linking that with our pricing data to be able to answer this question as to, does it actually add value to be invested in this instance, having a diverse workforce. So let me just find the right app. Here we go. Okay. Right. So that's essentially what we showed. And a big portion of what you do when you're a data scientist, which is the team that I'm fortunate to lead, is you're looking for ideas. And then you're testing within your data. Can you replicate that idea? Can you prove that it's true? Right? Can you help people gain insights? And so in this case, what we did here was to take in all of the various data that we have associated with the ESG factor and then break that out. And lo and behold, we do see this, right? So what we see was that the article that we read, which was this FT article, that it was focused in on this idea that gender balanced companies are going to have the highest performance. And lo and behold, that's what we see, right? We see that the red line represents those with a medium score. The other lines are either the extremes on one end, and you can see that fairly consistently, the companies where they've had a diverse workforce has tended to outperform. Now, there's a lot of the components that we'll talk about around natural language processing and sentiment and embedding models, et cetera, all go into that. But I think going back to my other side is, if you don't have a sense as to the so what, then you're always going to, how do you have a North Star when it comes to how you want to merge data or how you want to tie it together and how you want to link it? So I think coming back to this end of, as a portfolio manager, if you're thinking about supporting State Street investment side, what they actually care about is this going to help me make better decisions, whether that's in a systematic manner or a discretionary manner? And how you think about structuring the data, how you think about linking the data, how you make it easy for it to interoperate with other workflows, in this case with the price objective that they're caring about, will really distinguish whether you're having a good outcome or a bad outcome, right? So the other thing is that I just wanted to highlight within this as to, this paper is great, but this is something that you could have done for a long time, right? Take some analysis, work on it, get it to where you want it to be, copy it, put it in a PowerPoint presentation, right? Physical infrastructures are fine with that. Where the cloud really comes in and its real value proposition is, if one of my colleagues is having a conversation with a client and they have a PowerPoint deck, now that conversation has to somehow come to that deck and the conclusion of that deck, right? There's no real degree of freedom for the client to take it in a completely different direction or say, that's not really what I cared about, because now the conversation becomes abstract and it can no longer be grounded. That's because of batch-based processing times and the manual process of going from something that was in a database to a presentation to a slide into an ultimate presentation. What if you could just integrate all of that, right? So now we're talking about the cloud for the opportunity for doing two things. You can start to just in real time say, okay, well, that's the report that they came up with was in the US. well, what's the truth of what happens when we want to do it in Europe? Does it give the same answers? Maybe you were coming in talking to somebody who you thought was US, but now all they care about is investing in Europe. You have to be able to be flexible and be able to change, where in this case, actually, the story is different. It's actually the people who are the most focused on it, the pink line, and second most, or the most focused on it being the green line, and the pink line being the second most. So no, it's not about like just being balanced. You actually need to be committed to it, right? So you're going to get different insights, which will enable more conversations. And I won't go through every different iteration, but the key of that is that for this workflow, you could probably do this on a physical infrastructure. But if you're actually sitting there and you want to do it at scale and you want to solve problems for lots of people, now the cloud's main benefit is around horizontal scalability, right? Where you can add more and more machines at the problem that you're solving. And instead of technology having to tell the user, this is what you can do in this environment, now the user says, this is what I need to achieve. And if you are thoughtful about it and you've set up Terraform processes and Kafka queues and automated scripts, you can have horizontal auto scaling such that you can meet that demand, which is the same thing that's happening on your phones, right? A lot of people go to YouTube when something goes viral. A bunch of containers are going to spin up to be able to manage that capacity, and then they'll spin back down. That dramatically changes the way people are going to think about the world, right? Where now, in order to meet all of the demands that are coming out of technology orchestration, I no longer have to invest in huge amounts of rack spaces, right, up front. Because what always happens is if you invest in those huge amount of rack spaces up front, you end up paying for capacity that you're not using. And when business owners pay for capacity they're not using, technology projects get killed 2 years later, like clockwork, right? So the benefit of the cloud and the things that you're learning is that now you'll be able to actually drive innovations and scale the capacity in order to meet those, which will give business people the actual patience to be able to continuously invest in these innovations that are coming. So the key takeaway for you there is, as you're looking at doing something like sentiment analysis, you can start small now. You can work on teams that are trying to be the innovation centers and actually think that you'll be able to drive something that's going to go to fruition. Hopefully that's helpful in context as you're thinking about kind of where things are going. So now let's dive into a topic that's a little bit near and dear to my heart right now, which is improving search. And this is the next level associated with some of the sentiment analysis that you were talking about. So quick question. How many people have ever heard of semantic search or vector embeddings? Perfect. Okay, so let's start off with some idea around a use case for investing and how this plays out. So we talked about factors, right? Everybody remembers what that was. There's another concept that we're going to think about, which is in the market for my business school students, returns are a function of the CAPM model, right? And one component of that, which is more simple, is that returns are basically beta, your exposure to the market, and alpha, how good at you are at actually selecting stocks. Now, for the beta side, that's something that is also dramatically changing in the world. Right now, people just want to be able to say, I don't necessarily want to invest in Apple. I don't want to necessarily have to do the hard research to think about generative AI. I just want exposure to a bunch of companies that are going to benefit from artificial intelligence. And I want to wrap that as an ETF, right? That's a big way of where the world is going right now. Those are all thematic investing buckets, right? So where we went through before, you may say, I don't want to have to think about all the companies where their board directors are being thoughtful about the diversity of men and women. I just want to invest in companies where they're being thoughtful about that topic. That's a factor, and you're investing in that. So there's a lot of human approaches that can be done, but that's also a good application for generative AI and large language models. So let's talk a little bit about how that actually works and some of the concepts behind it. So in this example that I'm going to flow through is this idea of coming up with a thematic basket for the idea of artificial intelligence, right? And how would you go about that? And there's a couple of data sets, lots of data sets one could use to be able to come through that, but we'll look at company descriptions. What do they say about it, about themselves? And earnings transcripts and news. So earnings transcripts, then how are they talking to their investment community? And then news, just what are the articles around it? And let's see if we can come up with an idea of which companies are likely related to artificial intelligence based upon that. So we talked about like the company descriptions, the company transcripts, and the language that you're having there. This is an interesting challenge, and I'd love to hear more about like the NLP project and how you thought about sorting and pulling in the data. But dealing with unstructured data in text is very different from the way you want to deal with it in structured. How you think about quality controls is going to be different as well. There'll be some ideas around chunking it and how you want to break it down, and we can briefly touch on some of those things. But the first concept, and this is a lot of what powers Google search and like their BERT LLM models, is let's think about how this actually works and what's an embedding. So the first idea is, let's just say you have this string, hello world. The first step is called tokenizing. So you have to break it down into like manageable chunks that the computer can actually understand and interpret, or rather can bring in, fit in memory, and then transition that over. So hello world would be broken down into 2 words in this context of hello world. And then it has to be turned into a numerical representation. Whatever these numbers are in this case. And then we're going to pass that into a large language model, which is going to come up with this embedding. And embedding is kind of a word that gets thrown around a lot. I just want to do a double click into exactly what that is and try to make some analogies. So this idea of tokenization is powering, you can leverage the outcome of this to do sentiment analysis, and happy to show you on that side. But I'm going to focus on it in terms of similarity search. So this idea of tokenization is within any given byte and the memory constraints that you have, how do you want to actually break down the piece of information that you're trying to do the analysis on such that it's going to fit into the upstream process? And so as you're doing that NLP analysis, I'm sure that you realize that depending how you structured the data and fed that into the upstream model, even if you change nothing else about the hyperparameters, your results would become completely different. So within there, you can do all the transformations that you want, but then there's a secondary transformation layer that's happening within the models. And one core component of that is the tokenization and how it's breaking it down to be fed into downstream processes. Then it's turned into these ideas of embeddings, which essentially kind of, as you can see here, turn it into a string. So C has now, just in the same way that the numbers wouldn't mean anything to you if I put that as the array, the colors hopefully will tell you like that you can bring them together across different sides. So the light pink in this one is somewhat similar to the light pink in there. Not to say that I is similar to C, right? But it's understanding the DNA components. And my wife's a neurobiologist, so she always talks to me about this is similar to the way they think about DNA mapping. But I'm not yet confident enough in her analogy to share it with you. But just know that these subcomponents within the colors are the similar sides that the machine is now picking up on to represent even a simple word as I. And the idea of dense vector embedding makes it such that you no longer have to worry about the fact after it's been transformed that I and we are short, football is long, C is medium size. The size of the vector array is the same for all of them, right? And that becomes important when you're thinking about the merging and the analysis that comes downstream. Like just simply if you're trying to run a match and one array is a length of 10 and everything else is 100, you're going to have to figure out some transformation in order to be able to do that match across. So this kind of takes away, this portion that we're doing on the dense embeddings takes it away so that the machine no longer has to think about the size dimension as being an important component of its workflow. There are a lot of degrees of freedom that are taking place around these ideas that I'm trying to highlight here of the tokenization and the embedding string. And it's a good place for you to like dive deeper in your research. And if this whole topic is of interest, then getting that as a level of specialization is something that no matter who you are within reason, experience isn't going to be your differentiator there because it's new enough, it's important enough that it's going to be knowledge that's going to be your differentiator when you think about entering the workforce around this side. So in any case, in this place what we've done now is we've taken this JSON representation that has all these strings and all these words. It's unstructured, unwieldy, and it's turned it into a nice dense vector embedding, which is structured. You can control how long it's going to be, and will fit in as an array into all of your other numerical processes. If I wanted to, I could run a regression on this against like a time series regression, just like it was any other time series, right? Like, not to say I'd get any good results, but the interoperability of the data now will work. So a big portion of everything that's happening on generative AI is this idea of you both have garbage in, garbage out in terms of the data quality, which is why I joined Bloomberg. We have really high quality data, and that's going to enable the firm to win as it relates to this next AI frontier. And then two, understanding, like, right, this is all happening in an LLM, right? But I'm specifically, what I hope you'll take away from this is LLMs are somewhat vertically integrated right now. People are talking about that whole thing. You won't remember cable in a world where you couldn't get ESPN by itself, but everything used to be bundled in the cable industry as well, right? Dell computers, like all these things used to be vertically integrated and bundled, and the LLMs are bundled now. If you understand which portions you care about and focus in on the subcomponents of it, you can actually differentiate yourself, because eventually they're all going to be available as modules that will work as an interoperated portion of this ecosystem that is to come in the future. So really, we just spend all this time talking about this embedding model and this portion. And the way that either an LLM or a content flow will work is you have some data, you're going to feed it into this embedding model, you're going to turn it into this vector embedding that I talked about, you're going to store it in a vector database of some sort, then you're going to have an application that's sitting upstream, and this application is going to ask something, and those are going to be the business users' problems, right? And you're going to turn whatever it is that I'm asking for through that embedding model. So now it's also been transformed into that same dense vector space that it can be compared. And it's going to do a search against the vector database, and voila, it's going to return great results as if, it was able to figure out everything. So any questions on this? Because I just want to get the grounding of the logic, some of the key things, and then we're just going to dive in and see some of it in action. And then we'll talk a little bit more about some of the problems and considerations. But at this level and so just think about this as the application for your LLMs and ChatGPT. When you ask it a question, it's coming through here, it's going through that embedding, it's finding the data that it finds most relevant to whatever the question was that you asked it or you were talking about it in. And then it's returning back the pieces of information that are relevant, whether that's about the Knicks or the weather or whatever it is. It's going to get some information back into that application, and then that's going to feed it back into the LLM for its language generation. And so if you've noticed that as you continue to have conversations with ChatGPT, it gets better and better and better. It's that it's getting, through its interaction with you, it's getting better at this sequence of finding what are the pieces of information that are most relevant to you and returning back the results that are most relevant, such that it can be generative, which is creative about its response, right? That's kind of the way that it's flowing and working here. So if we go, yes. Oh, please, go ahead.
Michael, I understand the vector embedding in the role of large language models.
Yes.
But it seems you are doing a tabular data prediction here about the price and all the assets. And for that, I'm curious to see what do you do to combine these two together.
It's a great question. So if we were in a completely vertically integrated system, there would be nothing you could do. That's part of why I was highlighting the modularity of the side. So then there's another portion of generative AI, which is very good for time series forecasting and structured data. Instead of GPT, generative pre-trained transformers, it is generative adversarial networks, right? Where you're creating what's called a generator, which is coming up with predictions, and a discriminator, which is trying to discriminate whether those predictions are likely to be true or false. And over time, the generator creates predictions or forecasts on time series or anything else that the discriminator can't tell between its forecast and what actually happened. And now you put that generative adversarial model for time series prediction. For a variety of reasons, that's going to be better at the forecasting problem than GPT, and we don't need to get into too much detail around that. So the real way to tie those together in that type of forecasting would be that you have the adversarial or the GPT, this embedding side, which is more focused on search, finding similarities. And then you have a different model, which is conditional upon these similarities. So simple example, this can find really good similarities as to what environment are we in right now. And it will give you like 10 different 3-month periods that are very similar to this based off of the news. And then that becomes a condition that the adversarial network can use for the prediction problem. So everything that I'm talking about right now is around universe selection and nothing really to do about whether, in this case, creating an artificial intelligence ETF basket of names. That has nothing to do with whether it's going to outperform or not. It's just on the creation of similarly related companies leveraging lots of different data sources.
Attention mechanism for the forecasting task.
Sorry, what was the word you used?
Attention mechanism.
Yes, absolutely. Attention, absolutely. So since you brought that up, there is a very important paper that everybody in this room should read. Attention is all you need. How many people have read that? Okay. For everybody else, put it on the reading list. Attention is all you need changed my life. Very much so. I always knew that we were going to be in this data economy side, but there is a problem in terms of getting a machine. This is why I'm so convinced that the embedding mechanism that's here will one day be exposed and hitting lots of different problems. When you think about what I just talked about for generative modeling on time series forecasts, you have this big problem in anything else, and it's in your life, right? You do something, or yeah, let's think about that. You do something, and today it was successful, and it was successful yesterday, but you do it tomorrow and it didn't work. So does that mean like it doesn't work anymore? Okay. So this idea as to how we make those decisions as to when we want to change our learning rate, essentially is what it's called in machine learning. How long that should be of a window you look back on versus how short for making your decisions. That's an idea of attention. Right now you're all seeing me, but there's like a million things that are happening around us that we're blind to because our mind is filtering out what our eyes are actually putting back to our brain and our brain wants to bring in. Because the brain, if it would be overwhelmed, it only has so much capacity. So it's the same problem for an ML AI algorithm as it's learning and it's adopting, which time period in this case should it be really paying attention to and making its decisions. You might say right now, if you've been at the market for many years, this reminds me of the rate height tightening cycle of X or Y and Z. And that was a big problem for me was I was young, and I remember hearing people say, this reminds me of things that I'd only heard about like at the dinner table. I said, it's going to take me forever to get this level of experience. Why can't I get a machine to be able to do this whole thing as well? So essentially where the world will end up is there will be a component of the system which is leveraging these attention methods to determine where do you want to pay attention to, and then other more finely tuned prediction and AI methods that are taking that into account for their ultimate decision making. And that was something that transformed everything around generative pre-trained transformers and got us to the world that we're in right now, and moved away from this idea of LSTM, which is long-term, short-term memory components, but are kind of hard to adapt to a world of having a more flexible, on-demand side as to what the learning rate's going to be. Hopefully that's helpful, and that's a good question. So all of that is the cosine similarity, etc. So going back to putting this into practice, if I may. So the last portion, let me see if I can find this. I have a million apps, as Robert will tell you. All right, here we go. Okay, so now let's bring this into, I went too far. Let's bring this into concept around two things. So what I have here is we just break it up. I've loaded this with 3 different large language models: Roberta Large, Roberta Multilingual, and Distilbert, right? And I've also loaded it with or in Teams, we've loaded it with company descriptions and company transcripts, as I was going to talk about. And to just give you a concept of what I just talked about, let me ask you this question. If I were to put in, and then I'd like to just play with it with you, COVID. And my basket is around, so I want to create a thematic basket around the idea of COVID during that time period. And I do it on company descriptions. What types of companies do you think my portfolio is going to be populated with? Pfizer, Moderna. Okay.
Staffing, that was sort of like maybe that required peer-to-peer interaction, like in person, like user carts maybe, or
Interesting.
Something like even something like Costco, I guess, before they.
That's really cool. So you're wrong right now, but
I'm definitely wrong.
No. We're going to come back to you because you're actually correct.
Oh, sick. I love being wrong.
Isn't it great when you can be both? All right, so let's run this. So now we have COVID. We've run this on this revert to large model, and the first set of people were correct, right? We're getting a bunch of like biotechs. Novavax is a clinical stage biotech company. Pfizer's in here somewhere. Moderna's in here. There's Moderna at the bottom, etc. And as the first group of people said, our portfolio is now 85% or so, 84% healthcare related. Now, maybe the 5% and 10% are the types of companies that you were talking about, but they're actually people that are very closely related to these healthcare companies that were brought in here.
People that are like 95 masks.
Yes, exactly. That's the type of people that they're bringing in here. So you were wrong there, but I said you were also right. There's a couple of degrees of freedom we could do. We could play with different LLMs, right, to see if the results are going to be different. But regardless of the LLM, they're all going to come to similar results, and you'll be wrong in all of these. However, yeah, it's great. But now let's think about what happens if instead of looking at company descriptions, we look at company transcripts. I'll tell you the result and then tell me your intuition for behind. So now, and I'm sorry, like my dimensions are looking weird here. I apologize. But let's see if we come down here. Let's see this. Okay, whatever. You can get the results. So now instead of an 85% portfolio of healthcare, we have a 35% healthcare portfolio, 20% in communications, 10% in technology, 20% in consumer staples. The types of companies you were talking about appear here now. We didn't change the methodology. We didn't change the query. The only thing we changed was going from company descriptions as a Bloomberg data set to company earnings transcripts. Why do you think we got such a different result? Please.
Scripts as opposed to just like a description, because even though it doesn't describe the company, it actually relates to what they're doing. Because if you're a communications company, I don't know, like say you're Zoom, it matters that people need to communicate online now because of COVID. So you're going to be talking about those things.
Who agrees with that? Why do you agree with that? Sir, right here. Yeah. You.
I agree with him because people will need to find a new way to communicate with each other when they're like in quarantine and all that. So they'll look up to like Zoom and other platforms.
Yeah, it's absolutely correct. So yeah, you're both correct there. Versus company descriptions, where it's narrow about what it is we do. And so the LLM was able to figure out COVID is related to healthcare, and so now let me find cosine similarity matches with other companies that are talking about the same thing, so healthcare is going to pick up. Importantly, nothing in our data told it that COVID was related to healthcare, right? That's where this broader large language model of knowledge and corpus, it just happened to know that. And we as an organization didn't have to do anything, right? We just played a portion of that and we added to its knowledge base. So that's an important thing as to like you're doing sentiment. It's all a function of your data, right? Like all of this is high quality data, but one data is specific to one problem to be solved. Another data was specific to another problem to be solved. And because to your point, the earnings transcripts had a diversity of conversation and language that was taking into it. Now the LLM did this, which is now what we see here is in this embedded vector space, how is it that the LLM, the embedding station of it, is representing the universe of the S&P 500, right? So off of company transcripts, it's figured out, we didn't tell it specifically, we added these color codings by tying in the BICS classification codes. But it's figured out like, okay, healthcare companies are kind of similar, or these set of companies are kind of similar. We later, just for coloring, put on that that's healthcare. So it's figured out healthcare is over here. It's figured out consumer staples are a little bit different. They're over there. Financials kind of underpin the whole ecosystem. They're down here. And et cetera over there. And then what it's done is what each one of these X's represent is the query that we put into it of COVID. And it's transposed that same question to find the companies that are most likely related to it within this embedded space. And if I just to graphically show this so that you really take this embedded, I really hope you'll understand this concept and your professor will let you do a cool project around that as well. So now if I go into company descriptions and we just look at the same layout. Now here, again, it's realized that healthcare is over here, but now financials are much closer to healthcare. It's saying that technology is interwoven between everything else, right? So how it's decided to embed that vector space and how find the relationships amongst them is entirely a function of the data that's going in, as well as, which I won't go into too much detail right here, but depending on the model choice that I make, I'm going to get to different results. So whenever you're thinking about your projects, there's really only two things that are going to drive your ability to deliver high results, putting aside the infrastructure to do it. It's either your data or it's your methodology, right? And so whichever one of those sides, well, some of us have to deal with everything, but whichever one of those sides really drives your passion, follow that and then figure out what's the upstream application that you want to continue to move off of there. So we've done that there. I think that's fine. The last component, oh, this is what I wanted to highlight in terms of just showing you numerically what I was highlighting here. So for those who really do want to like dive into the details of hyperparameter tuning and like the AI behind all of this and which models you're doing, what we just showed here was, you know, there's Hugging Face. Everybody's familiar with Hugging Face, I assume, right? Play around with it, right? Download it, import it, whatever data you can get your hands on, you know, try to see what is going to be the difference here. So in this case, we actually are doing some sentiment analysis. And the question that I had when we first started looking at all this was, if we just load in all these earnings transcripts and we throw at it a couple of like the Bloomberg LLM models that we have access to and that we can play with, what's going to be the difference between Bloomberg models that we were able to train on our own data versus models that we were able to train just externally hosted? And so what you see here is that when we're asking a question about, is this piece of data market related or not market related, then Bloomberg, we blew out everything else that's available there, right? We really did a really good job, and that's because we had been trained to understand market related data. But then when it came to like sentiment analysis, is this positive or negative? Facebook probably has been spending a lot more time thinking about sentiment than we are. Their data, as we go back to it, is more fine-tuned towards likes and loves and sentiment around there. And so you can see that we're not really as good as they are, right? And like that there's if you look at the greens versus the red, the externally hosted models have much more of a differentiation versus our models where it's really good at figuring out whether this is about market-related context. but less good about whether that's going to be positively or negatively viewed. So that's where fine tuning comes into, right? This is an example of fine tuning where we start off from the same base corpus of what's publicly available. Our models are really much more focused around adding on a bunch of financial data, news data, text data related to financial markets, less so around Twitter and likes and clicks. And as a result, you shouldn't be surprised when your models have different results around them. All of them are incredibly valuable, and in this modular world, will be able to be interconnected. But it's about what data do you feed in versus what you feed out, and what do you prioritize when you're thinking about the fine tuning, and how is that going to lead to trade-offs moving forward. So there's a lot more that we can go into, but I'll leave you with this last thought, which is we talked about like the phases of this technological revolution, and I used to call it, what did I call it? The data economy. The next was the artificially intelligent future. And I think that that's kind of where we are. We're still in a place where it's about what can you do. And there's somewhat of an acceptance that let's see what the machines can do, continue to put humans on top of that, and use it as an automation and a cost reduction and an efficiency type of flow. That's because in order to fully close the loop and fully automate things, you have to be able to trust what the machines are coming out with. And with LLMs, has anybody heard of the phrase hallucination as it relates to an LLM? What is a hallucination?
It tends to predict something else that you don't want to, there's something that you prompt about, but that's not that he is generating or the model is not generating. It's because the model is not trained on that particular prompt, or the prompt that you gave doesn't, it doesn't take the entire information. And for that, maybe today, data scientists are using RAG to improve or to reduce the hallucination.
Correct. And a core component of, does everybody know what RAG means? What does RAG mean? How about you? Yeah, somebody else tell me what RAG means.
Retrieval augmented generation.
Perfect. So that was the core component of retrieval augmented generation is embeddings. Because that was where I was talking about of the LLM now needs to know where to get the data to fine-tune its answer and feeds back the information that's related to it. So all of this, like, that's actually why I want everybody here to understand what embeddings are and how it's going to play a role in it, because we are currently at a stage where it's cool. Like, you can stand up an LLM, you can give a fancy presentation, man. Like, I've spoken at AWS and CAT. It doesn't really matter. Like, I can give a demo on this and it's going to look really cool. But in order to actually use it, like, one, you have to get the scalability, the access to the GPUs, the horizontal, all those things that we talk about on the infrastructure level. But then you also have to trust the results, right? Like, it has to be valuable. That's the difference between like a POC, which are a lot of fun to do, and actually delivering some value is like, I have to be able to use these results, not just find that it's pretty, but then I'm going to go back to my Excel and do life the way that I always have done. So in order to do that, then we have to conquer this problem around having quality of results. And it's actually an easier problem in structured data and forecasting, because you know you were right, you were wrong. How do I know, like, if I were to say, hey, tell me about all the data that we have related to Tesla? How do I know whether it's a good result or not, right? Like, it may just be about corporate women percentage on the boards. Okay, well, that's relevant to every company, but it's also relevant to Tesla. And one person, that may have been exactly what they were looking for. For another one, no, I just wanted like the car count that was happening. So how we think about the performance of different models is incredibly important. And I think that that's a place that if you want to be a part of this next phase of LLMs, where the attention paper has come out, we figured out how to do gradient descent in like a search manner for attention. The core components have been built. But now it's about refining the sub-modules to actually move from interesting to valuable. That's the place where I think, like, as your timelines align with where the world is, It's going to be that taking these cool things that have just been built and actually making them valuable, which will require attention to detail at the subcomponents, which will require understanding the top stream workflows, as well as understanding the downstream components of structuring the data, plus the mid layer of the hyperparameter tuning and the attention to detail. No one person can do that if they just live in a silo, right? You have to be a Renaissance person of some sort in order to be able to succeed in this next phase of what's happening. You don't have to determine what it is you believe will come to fruition. You just have to be able to be thoughtful about how it's all going to interoperate at the base components level, such that either when you have that piece of salient premonition as to this is what the world's going to look like and what I'm going to do with it, you can go execute upon it. Or as you evaluate others who believe that they have that, you can understand how to execute and deliver upon it. So with that, I hope it's helpful. The world is moving into a focus of ideas to quality. This is what powers the trove of disillusionment that occurs in most innovation hype cycles, is people get really excited at it. We're at the peak of the excitement. And then in the same way that like you get excited about a Knicks trade, and then you can't wait to call him a bum because he's like missing a lot of shots. That's what this hallucination thing is, right? Oh, it's hallucinating this. It's hallucinating that. It's getting the wrong problem. Actually, hallucination may not be a bug. It may be a feature, right? That it can take something and instead of giving you this answer that you expect, it came up with some beautiful art. That's generative. If you're doing a poem, there's no such thing as it hallucinating a poem. But if you're trying to make a stock prediction and AUM's on the line and people's pension funds are on the line, well, yeah, it's a bug. So those are the subcomponents that we have to think about and adapt that. And so I'm excited for where you all are in your path today and where you'll be in the future. And I hope that I will see great things out of the students from UConn. And I hope this won't be the last time that we get to chat. Thank you very much. Any questions? First, was this helpful?
Yes.
Sure? All right, cool.
I do have a small question.
Yeah.
So, regarding the accuracy of the score, for our case, the sentiment score?
Yep.
How do we actually know if the score is accurate? Because the problem that we're running into at the moment is we're getting sentiment scores and it's showing correlation to some extent, but how do we know that it's the most accurate that could make it? Because a lot of people rely on the data to predict their, future investments and stuff.
Two places. One of the reasons financial markets are such a ripe ground for AI is the response function that you're getting from the market and the price side, right? So if you said that let's just focus in on something where you look at like event-based trading strategies, event things, new announcements. If you say like, hey, this CEO's earning tweet was super positive and the stock goes down 20%, you're probably wrong, right? Or at least that needs to be opined into the decision making of it. So one is think about like what is the response associated with that and leveraging that as one component that goes into that feedback loop. And then the second one is because the truth is in the eye of the beholder, figuring out how to crowdsource the feedback loop of the prediction is really important to all these technology projects, right? That it's giving you a response, whether it's a generative LLM response or a sentiment response, and being able to say, for a human who has looked at that same piece of information, they agree or they disagree with this, they find this to be useful, they find it not to. And doing that at a level of scale that will give you a diversity of sides, then you can leverage like some more machine learning techniques to be able to grow what I would refer to as like a golden source, which is like human curated. You can then take that to a silver source, which is like very similar as what the human. So imagine you did this analysis on Apple's announcement. We scored as positive. And you throw it to everybody else, and now you get 98% of the class scoring it as positive as well. That's your golden copy. In order to do a silver copy, now you would look for as close as a representation of what that news article was about for Apple, and find them for Tesla and Google and everybody else around that, and try to map over that response function. So now that's your silver. It's the same problem that you were trying to solve, which is human curated, but now just scale to a broader universe. Then you get to a place where it's large enough that now you can add that as a component of your training and your fine-tuning on your actual model. Right? So both a response as to like what is the actual objective that this sentiment is trying to be leveraged, and seeing how would the user use that, and training the model as to that response function just by shifting the time period, and then doing some human curated side that you can ask the person, given the same piece of information for an educated person, would you have gotten to the same level? And that's a big improvement that ChatGPT made in their, I guess this was like their July release, of moving to, what do they call it, like human augmented human review. It's like, essentially, I forgot what the acronym was for it, but essentially that the main difference between one of their releases was their results had gone through a human review process, and that was meant to try to reduce its hallucination as they built out towards the RAG model that we talked about.
So more testing of data. And more
scoring of the results.
More
classification.
Scoring of the results.
Okay.
Figure out a way to score the results and train that back, feed that back into the training loop.
Great idea. We're going to use that. We're going to send that to the analysts covering that stock and see if they agree with the scores.
I think it'd be
Great
better
idea.
because that way the recording will catch.
Oh,
all the
that's fine.
answers.
You're fine.
Are you sure?
Sure.
Yes,
I'm going to have a loud voice.
Okay.
Anyone else have questions?
Anything else?
Yeah, I'll ask you a question.
Sure.
Let's see. Do you think AI and all this artificial intelligence stands to create more jobs or take jobs away? Take more jobs away?
If you look at it as a student of history, every innovation cycle, jobs grow. This will be no different. Jobs change. This will be no different. So you look at, when I was sitting in the lobby meeting today, McKinsey. Who knows what McKinsey does? Global consulting firm. One of the most prestigious things you could do, like coming out of grad school when I was coming through. They put like 3,000 people on notice, like you need to improve your performance or you're getting fired. Now that's interesting. Every automation cycle has usually hit the lower education component of it. McKinsey's hiring people from Wharton and HBS and all this other stuff. So this displacement cycle is coming for the thought class, the intellectual property side of our workforce. So you'll continue to see layoffs in technology as now people are using LLMs to do the text to code and checking things. But it's the most nimble segment of our workforce that's being impacted. So it will actually just be redistributed into other intellectual property centers. So I think it will certainly continue to drive innovation, continuously force people to upskill, to do other things. There may be some sides that are completely dispersed, like how many like horse cab drivers do you see after the car came in? But people are still doing things, and that's why I think it's important, particularly for your generation, to not be too focused on what things look like today and try to think about what they're going to look like tomorrow, because there's going to be a big change in it. But if you're doing things where it's just highly repetitive problems to be solved, and it's just doing the same thing day in and day out, and it's kind of like mind-numbing, regardless of what that is, an LLM should do that for sure. AI will do that better, faster, cheaper, but it will free us up to do more creative things and to think about how we're incorporating that into our workflows. So, but certainly this is a moment like the internet, it's a moment like the car, it's a moment like the Industrial Revolution, where everything is going to change, and it'll be really, really cool. I'm really excited for where you guys are. Yes?
So for the large language model or foundation model industry, do you say it will go? Will it become a winner-take-all industry like social media, or it will become a cloud computing industry that there are several big companies there competing, so that all of us benefit from this?
The latter. It'll be like, in my mind, this is a capital intensive problem to be solved. So there will always be incredible synergies to scale. So that could drive like a winner takes all. In order for things to truly turn into a winner take all market, you need two things. You need network effects. So the more people that are on there, the better my service becomes. And you need a cost of switching, right? In order for the market to actually tip towards winner takes all. So with AI, there are certainly network effects that the more people come on, the more user response I can have, and then the better my service can come. The tipping is a different question, because as long as it stays modular and components get put into subsides, and we live in this open source world, the cost of switching isn't that high, right? Like in what I just showed you, within reason, whether I have one LLM versus the other LLM, I'm going to get to fairly similar results. Otherwise, my problem is too finely componentized there. So I don't think we'll get to a place where ChatGPT is like the only answer or anything like that. And then there's another side of it, which is business interests. In order to tie this, people have to say okay with the data. And you have firms like Bloomberg who are like, hey man, like our data is very valuable and you can't just put it anywhere, right? And everybody else, like other people who won't say it's valuable, but say my healthcare patient record stuff is proprietary and you can't just put it there. So I still want to use it, but you have to figure out a way that I can take your base model and I can fine tune it on my problem to be solved and my data behind my firewalls, which the cloud's going to make that incredibly. Imagine like if you were physically somewhere and I had to go take my LLM and like put it on your infrastructure somewhere, like, and you have to get GPU. That's just impossible. Spin up some instance in AWS, put it behind your entitlements and your identity management. Put in either you can put an API to the LLM behind there that's feeding into it, or you can take a binary and put it there if you're really overly sensitive about the potential for data sharing. But it's in your environment, and now it can work like anything else. That's called edge computing for anybody that's interested in that side of the world. And that is completely the future, for sure. So I think like what we'll have is some like foundational models, which will be just like the Facebooks, Googles, Amazons. Who knows what Bloomberg will decide to do with ours? But you know, it's not going to be in that level. Each major each company that has a lot of data anyway, has a lot of compute, will have their version of the LLMs, and then there will be some sort of an orchestration layer up top that'll help you decide which one's better at this or that. And then the true winner-take-all-ish of the user share will be the one who decides to be the most flexible and thoughtful about how they interoperate into other people's workflows and figure out how to give people the control of their data while still getting enough back from that interaction that they're bringing it back to their master models to improve that. And if you think about what's happening on my phone or your phone or my watch, that's what's happening in edge computing. The master model is sitting on wherever it is. You have a copy of it on your phone. As you do things, the master model is adapting to learn you and your interaction cycle. It's not sending back to Apple or Google any specific information about you, but really it's sending back how its hyperparameters changed as it learned about you. And then that is getting sent back as a JSON to the master, which through that transformation of the hyperparameter leads to better hyperparameter tuning, and that's why Apple's they're going to win for sure. So yeah, good question. Hopefully that's helpful.
So, as I understand it, a lot of models are trained on basically like the words. Like, if it's probably taken from like a video or a long speech, it's like going to analyze the transcription of that. I've worked around and played with trying to make a few RVC models, and I was kind of wondering, in the future, are we likely to see some sort of sentiment analysis when it comes to not just measuring the words used, but also the tonality of how words are said?
Oh yes, where that feature already exists. So it's a multimodal. I forget which announcement it was from ChatGPT where they moved from text only to multimodal. That's the portion that's picking up on it. So now you can deal with unstructured text, you can deal with images, you can deal with video, you can deal with sound, and that is just another piece of information that goes through that same flow that gets appended to it. And there's a lot of words or work being done around that, around acoustics, ties back into music, and like predicting hits is actually where a lot of that started, as the record companies were thinking about how to automate their A&R departments. I had a friend that went to Berklee College of Music, and when I was in grad school, we actually worked on a kind of similar application of sentiment because he wanted to like automate and come up with like a digital record agency, and I thought that was kind of cool. There's a lot of stuff that's already happened in that direction, and it'll continue. Yes, sir.
I have a specific question on our project. We're trying to understand how we would adapt like magnitude of the sentiment score, and how would we kind of bring that into the overall scoring of the document? The magnitude of the strength of the words in that.
Yeah.
We're actually doing the conference calls.
Yeah, that's an interesting question there. So when you say the magnitude, give me an example just so I make sure that we're using it in the same sense.
Just the strength of the words within the score, which the
And
veracity.
bringing up the words up to a sentence level and
Right.
up to a, okay. So it's depends on the core answer to that is the normalization side of there, right? Like that gets into the tokenization. So do you actually want to be focused at things on like a bag of words on a word level, or do you want to focus on it more on a sentence level or paragraph level? Depending on how you, my advice, thinking about how you're going through that, is try to focus on your chunk size of being at least on a sentence level, so that you don't get too caught up in any given word. Right?
Just to elaborate on that, at the moment we are doing it on a paragraph level, so it gets more context for each section of the earnings call. So we pick out the keywords first, and then we track it back to the earnings call. Pick out the paragraphs of which the keywords are, or like the paragraphs which the keywords are contained in, and then we just run it through the model.
Okay, so you're doing a bag of words, keyword search,
Yeah.
and then from that, those chunks are what's being fed into your actually sentiment model. Yeah.
We're actually categorizing the conference call based on different topics: earnings, inventory, gross margins. So we have a categorization, and then we're scoring each categorization and rolling that up into an entire score of the document.
It's interesting. Yeah. So that's a reasonable approach. So where are you finding challenges or issues with the scores as a result of that?
We haven't really found issues. We're going to have to validate, and you gave me a great idea. We're going to send it out to the analysts to look at it. The curiosity is, do we accept that score, or do we approach a magnitude on top of that score? And give them variations of scores. That's kind of other thing that we were looking to do.
It's certainly interesting. So I don't think that the reoccurrence of any given word is likely to drive that difference of a problem. But if what you're trying to do is thinking about how do I tag it to different topics and then run it there, then that absolutely makes sense, and it's something that should be an important component of the forecast and the classification method. That portion that you're doing, that would be actually very well suited for embeddings, where you provide it as sentences or paragraphs, whichever side you're doing. You feed that in, the few topics that you're currently doing like a bag of words search around, just swap that one component for the embedding side to return back the pieces of strings that you want, and then run it continuously through, as you otherwise were doing, through your sentiment analysis model. I think it should improve some of the results as you're doing, because it'll take care of some of the normalization in terms of the frequency and the magnitude in the sense of the words. But I understand that. That's an interesting approach.
Anyone else?
I have a general question.
Sure.
So you were doing a lot. You were doing a lot of things at the beginning stages, and you were exploring things that other people weren't doing during your career. So how does one, or like students for us, in this case, how does one explore a path where other people haven't covered it? Because there isn't like a lot of documentation that you could browse and explore. Like, so how does one learn something that other people haven't done and explore it?
Start off by doing is the first place. Understand that. Try to dive a level deeper in terms of the components, and then mix and match pieces of different problems to come up with a solution to a new one. Would be my first advice if you don't really know where it is. And then as you replicate what somebody has done, and this is how research is done in quantitative shops all the time, right? Like, you start off with a paper that you find really interesting, you try to replicate it. You can never really replicate a researcher's results without access to their code. Maybe you call them, maybe you learn, maybe you think. Depending who you are, they may answer, they may not. But because you don't have access to it, you try to solve that same problem that they said that they got this magical result from in the way that you do it. Now you started off replicating down this path, but a slight variant leads to a completely different discovery, right? So I think that's really the thing of dive deep, look at research, look at that ESG thing was because of a news article that we saw, see what's happening in the world, see if you can figure it out. Most solutions are available on Stack Overflow. Ask ChatGPT with the text to code side of it. And then as you get your reps at bat at doing things that others have, build upon that with your own kind of flavor and sauce. Cool. All right. I have a newborn that I need to get to, but this was, this is a true pleasure. I look forward to keeping in contact, and can find me on LinkedIn and we can stay in contact. Awesome. Good?
Yes. Thank you so much.
Thank you, man. Was this helpful?
Yes, it was a pleasure. I'm going to do so much Googling tonight. As soon as maybe after sleep or before, I haven't started.
Good. Very good.
Thank you.
Good. I'm glad it was helpful.
Is that you?